when there was no continent here. This was all underneath, this is all oceanic plate. There was no continent, and basically the country, the North American continent ended here. So this is all underwater, but the Juan de Fuca plate is offshore, part of that ring of fire that you described. And it was subducting, it was diving underneath the North American plate. When that happens, because it was moving underneath the continent, it created volcanism. The Cascade Mountains eventually came up, but first, because the ocean had vents like Hawaii off the coast, it had aggregated lava underneath the water, and when that subduction happened, all those little chunks aggregated, and through this process called accretion, we actually built up chunk by chunk a continent, a sublayer called Silesia. And Silesia is the basement rock, the first rock that created the continent and built out this way. Now afterwards, we actually had a format upon which we could aggregate other rocks. And the first thing that happened is there was a fissure out in the junction of Washington State and Oregon and Idaho out here. And in these vents of volcanism, lava flows came out and they came across the volcanic valley. They call them the Columbia River flood basalts. And they came down into this area, down into Salem, down into this region, and they created a volcanism uprising concurrent with the plate going underneath, the Cascade Mountains building here, and these mountains rising up under the pressure of the Juan de Fuca plate. So we have these valleys already, and so when this Missoula flood actually is out here, out in this region,
we're further up.
yeah, it's actually out here to the east in Missoula, Montana. The ice age had ended, so an ice dam melted and broke and brought all these sediments down into here. And the sediments, it's a sedimentary underlayer. And then afterwards, the winds came up and it blew loose. All of the Chehalis Ridge is loose. The granules of magnesium covered with wind-blown volcanics up in this area. Sometimes they aggregated into this area in the Eola Range on the far side. On my side, we don't have loess. It's only volcanism that's uplifted. But this entire mountain chain that we're on, like I said before, is a fault line, and it rose up as a fault block, and all of the volcanics tilted to the east. And so our hillside is a volcanic table that's tilted east. If that's helpful to you too.